All right, good morning. So welcome back to Calculus 2. We are going to be talking about Taylor polynomials, and all I'm going to say is, wow, they were not nice to us on this problem, okay? So this is a lot of arithmetic. Don't be afraid of the bigger numbers, but because we have calculators, but this is what people used to do, okay? If we want to approximate this, I don't know, a fourth root, we want a polynomial, this is just going to be better, okay? So here is the idea. They were going to want us to do this as a fraction. Okay, so we're just going to have to deal with the fact that that's going to work. So I would break this up into different parts. Okay, so we have, what is our polynomial, or our value here, function? This is equal to 3 times the fourth root of 16 plus x. I'm going to stop that. I'm going to turn this into a calculus problem. This is 3 times 16 plus x raised to the 1/4 power. Okay, so we're going to have to deal with some fractions here. Okay, so this is the original function. Okay, so it's not so bad. If I go ahead and I find my first, it's not p, p is the polynomial we're going to get. This is fx. Okay, so this is our original derivative, this is our original problem. Our first derivative, okay, this is going to be 3 times 1/4, okay, 16 plus x raised to the negative 3/4, okay, because the 1/4 comes down in front. F double prime, let's take another derivative. So we have 3 times 1/4 times negative 3/4, okay, times 16 plus x raised to the negative 7/4. Our third derivative, okay, third derivative, that's 3 times 1/4 times negative 3/4 times, this is going to come down to, this is negative 7/4. Let's make that a 3, okay? And again, 16 plus x raised to the negative 11/4, okay? So this is 1/4, okay, that comes down, that's -1. This guy comes down, 3/4 comes down, that's -7, it's another 4. 7/4, that comes down, that's going to be 11. And then finally, our fourth derivative, because that's what we're going to need, okay? This is going to be 3 times 1/4 times negative 3/4 times negative 7/4 times negative 11/4, 16 plus x raised to the negative 15/4. Okay, so why I did this is I'm just trying to leave myself a trail of breadcrumbs, like where did these numbers come from, how am I getting them, and what's the trail here. Okay, so 16 just to the 1/4, okay, that's 2. Okay, so you can go ahead and try that out if you don't believe it. Okay, we could say, okay, that's 16 caret parentheses 0.25 or 1/4, doesn't matter. Okay, but we're going to end up with 2. Okay, I got mine from the Inchworm song. You guys will do calculator, I guess, but whatever. Okay, that's 2. So when I've got this thing in here, we've got 0. So what if I just make a 16 to the 1/4 is 2. 16 to the negative 3/4 is going to be 1/8. 16 to the negative 7/4. Okay, and some of these I don't know. Okay, but if we go 16, if we do 2 raised to the negative 7 power. Okay, what's 2 to the 7th? Okay, we know that the negative just means it's a fraction now, so this is just 1/28. Okay, 16 to the negative 11/4. So remember, x is going to be 0 here. Okay, so that's just what's going to be left. So again, we're going to have 2 to the negative 11th. Okay, so that's going to be 1/2048. Okay, back in the 80s, they said you're really going to have to know your 2's powers. Okay, and the 2 to the 10th is 1024. So we just double it. That's where we get 2048. To be honest, that really didn't come true. Nobody needs to count binary very much. Okay, and then we have 16 to the negative 15/4. This one I don't know. I stopped at 10. So we have, so this is 2 raised to the negative 15, or 2 raised to the 15th power under 1. Okay, so 2 raised to the 15, that's 16 to the 4th. 16, yeah, raised to the 1/4 power, that's 2. 2 raised to the 15 is that huge number, so that's 1 over 32,768. Just there. Okay, so that's my value of the function, right? We're gonna plug this in into all of these pieces here. Okay, and the reason why I'm doing that is because, yeah, this is a big arithmetic problem, and they're going to get mad at us if we don't get exactly the right answer. So let's do it in pieces, so we have a chance to, like, well, is it making sense for the errors here? Okay, so that's all of this. The last thing we're going to have to deal with is, this is going to be an x to the 0. This is going to be x to the 1 over 1, x squared over 2 factorial, x cubed over 3 factorial, and x to the 4th over 4 factorial. Okay, 1 is 1, 2 factorial is just 2. Okay, 2 factorial equals 2, 3 factorial equals 6, 4 factorial is 24. 4 times 3 times 2 times 1. Okay, so we have all the pieces laid out. All right, so now it's time to start putting them together here. Okay, so my polynomial here, okay, for the first one, we're just going to have 3 times 2. Okay, so this first one is just going to be 6. There is no x's in here because it's x to the 0. We're going to be okay. For the first one, okay, we're going to have 3 times a quarter. Okay, so this is plus 3 times a quarter. Okay, 16 to the negative 3/4. This is times an eighth. Okay, we just have an x. Okay, divided by 1, so we don't have to mess with anything. Okay, the second derivative here, we're going to have a negative. So 3 times 3, that's going to be 9. So we have minus 9 over, okay, we have 4 times 4 here, so that's 16. Right? What is my 16 to the negative 3/4 here? That was 128, 1 over 28. Okay, we have x squared over 2. Okay, for my third one, okay, we're going to have 2 negatives, so we're going to end up with that. Okay, so this is going to be what? 4 times 4 times 4? I have no idea. Yes, I do, but it's 128, but who knows? 120. Oh, how about 4 cubed? Okay, so not 128. It's 4 cubed, 64. Okay, so we have over 64 here. Okay, and we have 3 times 3 times 7. Okay, so that's going to be right, that's going to be 3 times 3 times 7. So 3 times 3 times 7 is going to be 63. Times, what is my power issue here, right? So we're on this one, right? So we are at 16 plus x raised to the negative 11/4. So that was 1 over 2048. We have an x cubed divided by 6 here. That's my eraser. 3 times 2 times 1. Okay, 3 times 2 times 1. All right, so we're here. Okay, almost done. Last one. 1, 2, 3 negative signs. So this is going to be a negative. Okay, and then here we have 1, 2, 3, 4. So this one is 4 to the 4th. Okay, so we have 4 to the 4th power. Okay, it's 256. Okay, so it's under 256. And all I'm doing here is just dealing with the derivative parts of it first. Okay, so this is 3 times 3 times 7 times 11. Delightful. Okay, so this is, people used to do this by hand. Okay, they didn't have the internet, they didn't have TV, they had nothing. This was it. This was fun. Okay, because it took less time to do this, and it took to this is 396, 390, 693, 693. Okay, then compute fourth roots. This was better. Okay. I mean, I know when we're taking math classes, I know everybody is so happy with it. Everybody is, oh no, that's the right answer. Is it 3 times 3 times 7 times 11? 3 times 3 times, okay, I got it. Good. But all of this actually is designed to make our lives easier. Okay, I know you don't believe it, but that is the truth. Okay, and we have times 1 over 32,768. And then what's our polynomial is x to the 4th over 24. Okay, so that's what we're dealing with. Let's simplify this down so we can actually write the answer into the thing here. So this is p is equal to 6 plus. Now I'm just going to start multiplying these together. So this is 3 over 32. Okay, minus, and then let's see here, we have what's going on down there. We got a 9, or we got a 16 rather, 16 times 128. Okay, times 2 is probably something I used to be able to do in my head, 496. So this is what? Minus 9 over 4096. This is x squared. Okay, I got all the pieces here, so that's good. Plus, okay, I got 63 over 6 here. So I'm just going to say, well, I think this is too big for the calculator to make a fraction. So what I'm going to do is I'll try it. Okay, 64 times 2048 times 6 times 6. I know that there's parts of this that are going to cancel because I know 63 and 6, they're going to reduce a little bit. Okay, so let's say math, change it into a fraction, if you please. It will not do it. All right, so this is 3 times 2. So 63 divided by 3, right? That's just going to be 9. Right? 9 times. We'll be careful because we're this far into it. So 63. Okay. Divided by 3. Divided by 3. 21. Sorry, that would have been wrong. So this is going to be 21 over 64 times 20, 48 times 2. We canceled the 3 here. Okay, so that's what we're going to have. Because I was trying to be careful about that because I tried this a little bit before, and guess what I didn't do? It didn't cancel. And it told me, you are a terrible person. 48, okay, times 2. Again, these were all powers of 2. I probably should have been able to do this. Okay, but this is 262, 144. So this is 262, 144, x to the 3. Okay, so, and again, I'm not going to promise this is going to be the exact right answer because there's a lot of places to mess up. All right, the process is the important part. That's what I tend to grade on. Let's see, this is 693. How do we get 693? We went to this guy here, 3 times 3 times 7 times 11. 24 is divisible by 3. So this is 4 times 3 times 2 times 1. I will bet 693. 693 divided by 3 for this one. Okay. So that's 231. Okay, so this is 231. Okay, if I take that 3 out. Okay, we've got 256, 2 to the 15th, and then 4 times 2. Okay, so again, we could just count up powers of 2 here. Okay, and that's, we could reasonably do this. Okay, 256, just double. That's all this is doing. 32. It's a little bit out of range for the intro song, but that's what we have calculators. Times 4 times 2. Okay. So I think that is everything here that we got. I got the 4 factorial. We're okay. Okay, so this is going to be minus 231 divided by, okay, 671. It's a lot of doubling. Okay, so this is going to be what? 6 million, no, 67,108,864. So this over, okay, this over so I can read it. Okay, so we have 67,108,864 x to the 4th power. Okay, sure, obvious, right? And that is our polynomial for the Taylor polynomial for this piece. This is a terrible question. So it requires way too much arithmetic to do this to see if you're right. I'm not brilliant about that. But we'll type this in. Okay, so this was 6, okay, plus, and then we'll just keep going with this. So what are we doing here? That is right. So that's 6 over 3, 30 seconds, x, right? Let's see here, minus 9, 4096, minus 9 over 4096, x squared, okay, plus, right? Let's see here. We have 21 over, and I know it's 262 something. Just 144. Okay, we have x cubed. Right. Let's see what we have next. There's a minus, and this was the last one, right? 231 divided by, oh, that's easy. Okay, 67,108. So this is 67,108. Okay, 67,108, 864. Come on. 864 x to the 4th power. Okay, I'm gonna pause for a second. I'll show you something else. All right, so what I did is I just went over to Desmos here, and I did not want to have you type all of this stuff in again. I mostly cut and paste, and then just kind of did some surgery to make it work a little bit better. But the polynomial, the Taylor polynomial, that's the blue line, okay? And what we're trying to do is approximate it around 0, okay? So the further away from 0 you're going to get, the less it's going to be. Polynomials are continuous everywhere. This is going to eventually have a root that's going to be imaginary, so we're not going to do that. So it is going to fall off a bit. But you can see around 0, you know, actually pretty good region around 0, 10 to negative 10 to 10. Is pretty good. Okay, so you should be getting a approximation for this function with this polynomial. Okay, so you can always kind of look at it and test it to see first, like, how close am I? Now, if I put in a 42 here instead of a 44, you're not going to see it. Okay, nobody's going to see it. So let's go with the finale here. So we have all of that. Fingers are crossed. I'm hoping, okay, that we actually end up with something that is reasonable as an answer. Check the answer. Hey, look at that. We did it all. Okay. That was more luck than it was skill. Okay. So just to reevaluate, like, do this in very small pieces, try to organize everything and keep everything kind of like in different little parts here. Accounting paper and a really fine pencil probably would have helped. Okay, because all the numbers here just, they start to get a little bit big and it starts to get hard to keep track of everything. Okay, so I get that. But that is how you do a problem like that. Again, on a quiz, on a problem that I would grade, I'm looking more for your setup. Like I want to see you take the derivatives, how you're handling all of this, and then how you're putting it all together. If you forgot, like, oh, I didn't reduce here, like I'm not going to notice this. Okay, I want procedure and technique more than I care about accuracy right now. Okay, for you guys to do this. I had a an engineering teacher back in the Korean. He was a Korean War vet, and he was an engineer. And in order to do the problems, they would get about 6 engineers in one room, and they'd all work the problem individually, and then compare their answers. And if people were off, you had to rework it. Sometimes they would talk about it too, but you'd rework it until you all got the same answer, and then you would hand that in to your chief. Okay, and then you could go ahead and that's the bridge you were going to build, or that's the whatever fortification they were going to build. But they all had to get the same answers, okay, in order to make that happen. And sometimes, even though we have computers, it seems like that's still what we're doing. So if you ever end up with a problem like this, okay, you're running a lab and you've got to do like a big error calculation, I would assign the calculation to as many people as you could. Here's what we're starting with. Run your calculation and make sure that everybody's getting the same answer before you go off and say, that's going to be the one. Okay, so I hope that helped a little bit. This is a terrible test problem because there's way too many places for people to mess up. But even if it was going to be that, when I'm grading, I'm looking for like, what was your process? Okay, so that's really the important part here. But I understand, like, it's good to get accurate for the answers. Okay, I'm gonna let it go here because it's been a while for the video, and we'll post this. All right, so thank you. Ask again.